May 31st, 2013. The largest tornado ever recorded in American history was on the ground, moving, expanding, and headed straight for a car carrying 3 people who had spent their entire careers trying to understand storms exactly like this one. What happened in the next few minutes would change tornado science forever. But to understand why 3 of the most experienced researchers in the field were in that car, on that road, on that afternoon, you have to go back to where this story actually begins. Not May 31st, not even that year. You have to go back to a house somewhere in the Midwest, a television set, and a little boy who couldn't look away. Tim Samaras had been chasing tornadoes his entire adult life. Not for the footage, not for the thrill. He wanted to know what was happening inside them. Every expedition was a question that existing science couldn't fully answer. What does pressure do at the moment of impact? How do subvortices, smaller, faster funnels spinning inside the larger circulation, behave when they collide? How close does something have to be to a tornado's core before the rules change completely? These were questions that could only be answered one way. You had to go in. In the 1990s, Samaras began testing his instruments inside real tornadoes. F2s, F3s, F4s. Each run taught him something new, something the textbooks hadn't figured out yet. By the early 2000s, he had founded the TwistX Project, a small, dedicated team that spent tornado seasons crossing Kansas, Nebraska, Oklahoma, and Texas in search of the right storm. Their mission was precise: deploy scientific probes directly into a tornado's path and get out. Let the instruments do what no human could survive doing themselves. The probe he built for this was called the Turtle. Compact, heavily reinforced, capable of withstanding winds above 250 miles per hour. For the first time, meteorology had a tool that could sit at the edge of a tornado's core and transmit data back in real time. Subvortex movement, pressure readings, the invisible geography of one of Earth's most destructive forces. The TwistX team wasn't just collecting numbers. They were mapping territory that had never been mapped before. One moment stands above everything else from those early years. June 24th, 2003. Manchester, South Dakota. Samaras placed a turtle probe directly in the path of an approaching F4. When the tornado passed over it, the sensor recorded one of the largest pressure drops ever documented inside a tornado. The measurement ended up in the Guinness World Records. But for Tim, it wasn't about the record. It was proof that the method worked, that getting close enough was possible. By 2009, he had refined the approach even further. Near Aurora, Nebraska, cameras captured the main circulation of a tornado passing directly over a deployed probe, while smaller subvortices churned violently around it. Scientists had theorized about this behavior for decades. Now they had footage, direct field observation of how these structures formed and interacted inside a real storm. And the work wasn't only about tornadoes. Samaras had engineered a high-speed camera called the Kahuna, capable of capturing lightning at 10,000 frames per second. For the first time, researchers could watch a lightning bolt form step by step, traveling from cloud to ground in a sequence of images that the human eye could never have followed on its own. He was an engineer, an inventor, a scientist who refused to accept the limits of what existing tools could tell him. Over time, though, something shifted in him. It stopped being purely about the data. It became about his son. Paul Samaras had grown up watching his father disappear into storm country every spring. By his teens, he was already joining expeditions, Out in the open plains, Tim taught him how to read the sky, how to place probes, how to calculate distance and margin and risk. Paul learned fast. He had his father's instincts: observant, patient, precise. A month before El Reno, he posted a message to friends on social media asking what they had always wondered about his father and storm chasing. He was thinking about making a documentary, about telling the story from the inside. The 2013 season had already made its intentions clear before May 31st arrived. 11 days earlier, on May 20th, a powerful supercell had darkened the skies southwest of Moore, Oklahoma. At 2:56 in the afternoon, an EF5 tornado touched down near Newcastle. Within minutes, it had widened to nearly 1.5 miles. Winds exceeding 200 miles per hour. The tornado moved northeast through the suburbs, leaving a path of destruction 17 miles long. Plaza Towers Elementary School took a direct hit. So did Briarwood Elementary. Buildings collapsed into rubble while trees and cars were pulled into the vortex. The images coming out of Moore were unlike anything most Americans had seen in years.
Jessica, these families were advised by their attorneys not to comment, but these documents explain their frustrations.
While the rest of the world was watching those images in horror, Tim Samaras was trying to get to the storm. He never made it. Traffic gridlock in the suburbs of Moore turned into an insurmountable obstacle. The roads were packed with residents trying to flee in every direction. The famous turtles never left the trunk. The sensors sat unused, while one of the most violent tornadoes in recent memory carved through a populated area without a single piece of scientific data being collected from its core. It was a personal defeat. 11 days later, Samaras had another chance. May 31st, 2013. Oklahoma was suffocating under heat and humidity, the kind of afternoon where the air itself feels like a warning. Samaras had already read the atmosphere that morning. He posted to Twitter, "Storms initiating south of Yukon along the Triple Point. Dangerous day ahead for Oklahoma." He wasn't speculating. He was describing conditions he had read hundreds of times before. Whatever was forming near El Reno was going to be significant. At 6:03 in the evening, the first funnel made contact with the ground. It didn't look right from the beginning. The classic image of a tornado, a clearly defined cone descending from the clouds, wasn't there. What storm chasers saw instead was a chaotic wall of rain moving toward them, swallowing the horizon. Even veterans felt it. Something was wrong about the shape of this thing. What none of them fully realized yet was that the El Reno tornado was not a standard circulation. It was a multi-vortex storm on a scale that American meteorology had never encountered. Inside the outer rotation, dozens of smaller funnels called subvortices were constantly forming, intensifying, and dissolving, all while orbiting the main center of rotation at extreme speeds, each one capable of winds exceeding even the primary circulation. And because of this, the danger wasn't fixed in one location. It moved. It shifted unpredictably. The most violent zone inside the tornado could appear almost anywhere within its boundaries at almost any time.
Moving due east, and it's a large multi-vortex. I'd like to say the main circulation is probably about a half-mile wide, and there's individual vortices coming down that are more intense.
Samaras, his son Paul, and meteorologist Carl Young were traveling northeast of the tornado's starting point in a passenger car, attempting to get ahead of the circulation and deploy their probes. They communicated over radio, coordinating position and watching the storm's movement. The data they were chasing, real measurements of how subvortices behaved inside a record storm, could reshape what the science understood about the most destructive minutes of any tornado's life. Around 6:15 in the evening, the tornado began moving east-southeast. Then it stopped. Then it turned north and then northeast. An abrupt and unusual shift that caught dozens of chasers in the area completely off guard. What had been a manageable intercept position became a scramble. Vehicles repositioned. Distances were recalculated. The margin for error had already been cut in half. The team adjusted. They kept watching the distance. They were doing exactly what they had done hundreds of times before in storms far less dangerous. But this storm wasn't behaving like anything they had studied. Around 6:20 in the evening, the El Reno tornado stopped being large. It became something else entirely. Within minutes, the circulation expanded to a width of 2.5 miles, the widest tornado circulation ever recorded in the United States. But the expansion wasn't visible to the naked eye. A dense curtain of rain had wrapped completely around the outer edge of the storm, hiding its true boundaries from everyone on the ground. What looked like safe distance was no longer safe distance. The TwistX team believed they were clear. In reality, their white Chevrolet Cobalt had already crossed into the outer wind field of the expanding monster. At 6:23 in the evening, the tornado crossed near Highway 81. It was still expanding. The rain curtain thickened. Inside the vehicle, Carl Young said quietly that there was no more rain falling on them, that it had gone eerily still. Samaras answered. He said he thought they were in a bad spot. A moment later, another storm chaser, speeding east away from the approaching storm, captured the Samaras vehicle on a rear-facing dash cam just as the wall of rain closed around it. There were no more radio transmissions from the TwistX team after that. No final call, no distress signal. The channel just went quiet. The impact was instantaneous. Radar had measured wind speeds approaching 300 miles per hour inside the tornado's most violent zones. When one of those zones passed over the Cobalt, the vehicle was lifted off the road, thrown, and rolled repeatedly. Metal twisted apart. Equipment was scattered across the field. When the car finally came to rest, it was more than 2,000 feet from where it had been struck. Investigators later described it as resembling something that had passed through a trash compactor, compressed to 60 or 70% of its original size from the force of the rolling impact. Tim Samaras was still in his seat when rescue teams reached the car. Paul and Carl were found in separate fields. Carl nearly a half mile to the west. Paul about a quarter mile to the east. 3 people who had given their professional lives to the study of these storms were killed instantly by the one storm that had simply refused to follow any rule they had ever learned.
4 storm chasers and 4 others died when the tornado tossed their cars.
It's just truly unbelievable.
The El Reno tornado remained on the ground for 40 minutes. It left behind a swath of destruction across Canadian County and the surrounding area. More than a dozen people died that evening, including 8 storm chasers caught in its path. All of them were professional researchers. Others were enthusiasts who had followed the storm with cameras, completely unprepared for what it became. When investigators recovered what remained of the TwistX team's instruments and cameras from the wreckage, they found something remarkable. The onboard recorders had captured data during the final moments before impact. Measurements of the subvortex structure, pressure readings, wind behavior from inside the outer field of the largest tornado in recorded American history. It became the team's final transmission to the scientific community they had spent decades building. The last data set from the people who had given everything to make that kind of data possible. Kathy Samaras lost her husband and her son on the same afternoon. In the months that followed, she spoke carefully about the new reality her family was learning to navigate.
He wanted to have a positive impact in life. I mean, that was like one of his goals, to be able to contribute somehow to the world.
The work Tim had done, the probes, the turtles, the kahuna, the thousands of miles across Tornado Alley continued without him. Other researchers built on his methods. The measurements he collected over 2 decades became foundational to how meteorology now understands the internal mechanics of violent tornadoes. every improvement in warning time, every refinement in the models used to predict tornado behavior in populated areas, his fingerprints are on all of it. Paul had been planning a documentary about his father. He never finished it, but in a way, the story told itself. The El Reno tornado was the widest ever measured. 2.5 miles of circulation hidden inside rain, shifting direction without warning, producing subvortices that no instrument on the ground could predict. It broke every assumption the science had developed about safe positioning. It broke every rule the most experienced chasers alive had written through decades of hard-earned field work. It was, in the purest sense, a storm that exceeded what was known. And the man who came closest to understanding it was Tim Samaras, who had been trying to decode these things since he was a boy, sitting in front of a television set, watching a black funnel tear across a screen, and feeling something in his chest that he would spend the rest of his life chasing. He never stopped being that boy. Right up until the end, he was still trying to get close enough to understand, still convinced that the answer was out there inside the next storm, waiting for someone willing to go far enough to find it. The tornado took that from him. But it couldn't take what he left behind.